The first type of rational function we're going to take a look at graphing has a single x in it, and that x is located in the denominator of the fraction. It may have numbers being added or subtracted to it. Those would be h and k values, as we've talked about all throughout the year. Our domain is always going to be what would make the bottom of the fraction equal to 0. The biggest thing to keep in mind with rational functions is you never ever want to divide by 0. Well, in this case, some people tell me that x can't be 0, but that's not true. If I plugged in 0 for x, 0 plus 2 is 2, and dividing by 2 is not a problem. Instead, I have to think, what would I plug in for x that would make the bottom of this fraction equal to 0? Or, if you can't think that way, you can go ahead and actually just set the bottom equal to 0 and then solve that equation. Solving that gets me x equals negative 2, which tells me actually what I don't want x to be. That tells me my domain is x cannot be equal to negative 2. If I were to plug in negative 2 for x, negative 2 plus 2 is 0, and I cannot divide by 0. That'll also tell me the equation of the vertical asymptote. That's going to be at x equals negative 2. Those two ideas are linked together. There can be no graph at negative 2 because if I tried to plug in negative 2, I'd be dividing by 0, and I cannot do that. So let's go ahead and draw in our vertical asymptote at negative 2. Alright, next up in one of these examples, and this rule will change in our next video, so be ready for that. To find the horizontal asymptote, all I need to do is look at the k value, the number being added or subtracted at the end of the problem. And again, this only works when there's this single x in the bottom of the fraction. That k value will tell you what your range is. In this case, our range is y cannot be equal to negative 1. I can get all answers except for negative 1. That'll also tell me my horizontal asymptote. That's going to be the equation y equals negative 1. And again, those two ideas are linked together. So if I go ahead and graph that line as well, let's count down 1 and draw that horizontal line in. And those two asymptotes will define where our hyperbola is going to be located. And so the final portion of this is to figure out what quadrants. Quadrants is in quotes. You can't see me doing quote marks, but trust me that I am. These aren't really quadrants because I'm looking at my asymptotes, not the axes. However, we're going to use that thinking, whether we're in quadrant 1, which would be this section up here, or 2, 3, and 4, and so on. And so, in this case, to do that, I look at my a value. Because my a value, the number on top, is negative, I'm going to be in quadrants 2 and 4. So those two sections. When I graph these, I don't care about points. If you want to be more accurate, or if your teacher is asking you to be more accurate, go ahead and graph this on your calculator, which we'll take a look at in a few seconds to show you some things on there. But for me, I don't care. Just go ahead and draw your hyperbola in there, approaching your asymptotes, not the axes, with arrows on both ends. And so there's one branch of my hyperbola, and there's the other branch of the hyperbola. So to me, that's going to be a lovely looking graph. Let's take a look at the graphing calculator just so I can show you some things from that table. So we've just graphed this rational function by hand, but let's take a look at some things that we could see using the calculator if we were to use that. So I've entered this in. Notice I've used parentheses around my denominator, which is very important for these rational functions. We could also use them around the numerator. However, with one term that won't matter. But if you're ever in doubt, use parentheses. It's not going to be wrong if you use more parentheses. So let's go ahead and graph this one and notice some things about the graph. It appears very similar to what we graphed by hand. However, notice what's missing from this graph are the asymptotes. The newer calculators do not draw in the asymptotes for you because remember, they're not really part of the graph, even though to me, the asymptotes are more important than the graph itself. Some of the older calculators, if you're using one at home, may have drawn in one of those asymptotes, and it's just because it's an older calculator and it used to draw them in, but it doesn't anymore. So we can kind of estimate where that asymptote is located, the horizontal and vertical. However, one way to be a little more accurate is to look at your table. So let's do that. Hit second and graph to look at your table. So here's a bunch of points. If you did need to be more accurate, you could plot some of these points. One thing I want to point out though is there is one x value in the table that should have an error in the y column, and that hopefully you know is negative 2. You can't plug in negative 2 for x. So if we scroll up and look in our table, sure enough, there it is. So there's one way to find vertical asymptotes using a table. Look for errors in the y column. Let me go ahead and keep scrolling up in the x column for a while. In other words, I'm going to make x get smaller and smaller and smaller, more and more negative. What you may be noticing is that y value is getting closer and closer to a certain number. And the value that x is getting closer and closer to is negative 1. It's our horizontal asymptote. Now, it's never going to get there completely. In fact, if you're bored, if you want to hold down that up arrow, like I'm kind of doing, and
and keep scrolling smaller and smaller and smaller, you'll see that you're never going to quite get to -1, although the graph is getting closer and closer to it. So that could be one way, a very I think, annoying way, but a way to find a horizontal asymptote. Scroll through your x's and see what y is getting closer and closer to.